Hi guys! Today we're going to talk about stoichiometry. I know this word sounds weird, but actually it's not as hard as it sounds like. It's just a numerical relationship between reactants and products in a chemical reaction, and typically it's just a ratio of whole integers. You may wonder, why do we need to learn stoichiometry? It does us no favor. But actually you're wrong. We can apply it in our real life. So let's say if you were almost out of a specific ingredient, and then you could use the principles of stoichiometry to figure out how much of every other ingredient you would need to make the food. And after you calculating it out, you can make your food successfully. You may wonder, what did I mean by integers? So actually they're called coefficients. Their aim is to show the amount of moleculars in certain reaction, and they're usually measured in moles. Let's see the example here. If you're still confused about what coefficients are, then the 3 before hydrogen and the 2 before the nitrogen trihydride are coefficients. They stand for moles, like 3 moles of hydrogen can react with 2 moles of nitrogen trihydride. And that's it. It's super simple, right? I got you a question here to test you if you understand what I just said or not. I strongly recommend you to do these questions yourself first, and then after you've done it, then you can check your answers with me. The first question is that how many oxygen molecules react with 6 molecules of dicarbon hexahydride? You can see my process there. I put dicarbon hexahydride in different places, one in numerator and the other one in denominator. And in this way, I can cancel them out and leave 7 moleculars of oxygen on the top. And after calculation, we can know that 20 moleculars of oxygen will react with 6 moleculars of dicarbon hexahydride. I use the same methods for following questions, so I'm not going to show you again how to do this. You can figure it out by yourself. I'll leave my answers for you here. If you want to pause and do that again, you're welcome to do that. Now I am about to teach you a very important concept. It's called the mole bridge. A mole bridge is a relationship between the moles of chemical number 1 and the moles of chemical number 2. Before crossing the mole bridge, the initial units for chemical 1 must be converted to moles of chemical 1. And after crossing the moles bridge, moles of chemical 2 is converted to units needed for chemical 2. They can be in the form of moleculars, mass, or volume. Okay, here on the top we've got a skeleton equation, and we need to balance it first. If you don't know how to balance it, then you can go back to my last video and I'll show you how to balance a chemical equation. Anyway, we need to know what mass of tricarbon octahydride is required to produce 100 grams of water now. So in order to solve this problem, we need to use a mole bridge. So from my steps, we know that we start with the mass of chemical number 1 and we times it by the molar mass of water so that we can know how many moles of water is going to be used. Then we times it by the ratio between tricarbon octahydride and water. And finally, we multiply the consequence by the molar mass of tricarbon octahydride. And finally, we can get the answer, we can get the mass of the chemical number 2, which is 61.1 grams. And finally, we solve this problem. I know this is not hard, right? After practicing, you can master it. Everybody can. So thank you for watching my video today. I hope you enjoy it.